Good morning and welcome to Calvary Chapel of Marlton, our Creation Conference 2022. To those seated inside here and outside, I just want to give you a few tips of information ahead of time. If you need to use the restrooms, they are downstairs and to the left. And so help yourself anytime. We will have refreshments during the breaks, and those are going to be outside on the front lawn. And there's also book sales outside, so feel free to take a look at those when you have a chance. We're going to start with a couple songs of worship, and then when we're done, I'll come back up and introduce Dr. Lisle.
Good morning, everyone. Let's rise. Let's come before the Lord. Let's come into the presence of our King. Psalm 96. Let the heavens rejoice, let the earth be glad, and let the sea resound. And all that is in it, let the fields be jubilant and everything in them. Let every tree of the forest sing for joy. And come, let us worship and bow down near before the Lord our Maker. Father, we thank you for this day. Receive this worship, that at your name, Lord, we will bow and humble ourselves to give you this praise of who you are, the creator of all things. Receive this worship. Let's sing this verse. At your name, mountains shake and crumble. At your name, the ocean roar and tumble. At your name, angels will bow. The earth will rejoice. Your people cry out. The skies, endless praise. Yahweh, Yahweh, we love to shout your name, oh Lord. At your name, the morning breaks in glory. At your name, creation sings your story. And at your name, angels will bow. The earth will rejoice. God, your people cry out. Lord of all the earth, we shout your name. And filling up the skies with endless praise. Shout your name, oh Lord. Lord of all the earth, oh Lord of all the earth, we shout your name, filling up the skies with endless praise. Sing Yahweh, Yahweh, we love to shout your name, oh Lord. Let's declare, church. For there is no one like our God. We will praise you, yes, praise you. There's no one like our God. We will sing, we will sing. There is no one like our God. We will praise you, praise you. There's no one like our God. We will sing, we will sing. There is no one like our God. We will praise you, praise Jesus. Jesus, you are God, we will sing. Sing it out. Lord of all the earth, shout your name. Oh, filling up the skies with endless praise. Oh, Yahweh, Yahweh, we love to shout your name. Oh, Lord. Lord of all the earth, Lord of all the earth, we shout your name, filling up the skies with endless praise. Yahweh, Yahweh, we love to shout your name, oh Lord. Sing Yahweh, Yahweh, we Yahweh, Yahweh, we love to shout your name, oh Lord. Amen. Let's sing this truth. There's a reason why the curse of sin is broken. There's a reason why the darkness runs from light. There's a reason why we stand here now forgiven. Jesus is alive. Amen. So why we're not overtaken. There's a reason why we sing on through the night. There's a reason why our hope remains eternal. Jesus is alive. Praise the King. Oh, praise the King. For He is risen. Yes, praise the King. He's alive. Praise the King. Death's defeated. Hallelujah, He's alive. Oh, hallelujah, He's alive. There's a reason why our hearts can be courageous. There's a reason why the dead are made alive. There's a reason why we share His resurrection. Jesus is alive. Praise the King. So praise the King. He is risen. Oh, praise the King. He's alive. Let's praise the King. For death's defeated. Hallelujah, He's alive. Sing hallelujah, He's alive. In the grave could not ignore it. When all of heaven's roaring, hell, where is your victory? Oh, death, where is your sting? The world cannot ignore it. When all the saints are roaring, hell, where is your victory? Oh, death, where is your sting? The grave cannot ignore when all heaven's roaring. Hell, where is your victory? Oh, death, where is your sting? The world cannot ignore it when all the saints are roaring. Hell, where is your victory? Oh, death, where is your sting? Praise. So praise the King. He is risen. Praise the King. He's alive. Oh, praise the King. For death's defeated. Sing hallelujah. He's alive. Hallelujah. He's alive. Praise the King. Well, praise the King. He is risen. Praise the King. He's alive. Yes, He is. Oh, praise the King. And death's defeated. Sing hallelujah. He's alive. One more time. Declare it. Hallelujah. He's alive.
Well, good morning again and welcome. And for those that came in a little on the late side, just want to remind you the bathrooms are downstairs, wrap around to the left. And we're going to have 3 sessions this morning. And in between the sessions, we will have snacks out there. And when we're all done, we have make your own tacos for lunch. after the end of the third session. We also have 6 dozen mini torpedo roll sandwiches coming from ShopRite. So if you don't like tacos, we have sandwiches. If you don't like tacos or sandwiches, there's no help for you. We might have to send you to a doctor. So I appreciate you coming. I'm glad you could join us here. I'm always excited to do a conference on creation because, well, God is alive, Jesus is alive, and the Bible is accurate. And the Bible says God created the heavens and the earth, and frankly, I don't need anything more than that. And you could spend all day talking about why the Bible is faithful and reliable, and that's part of what we're going to get into this morning. So Dr. Jason Lisle is with Biblical Science Institute, but he was telling me yesterday he started with Answers in Genesis. So have you heard of Ken Ham and the Creation Museum? He worked with Ken Ham for a few years, and then he was with Institute for Creation Research, and then he went out on his own and started the Biblical Science Institute. So we invite you during the breaks and at the end to check out the materials that he has for sale out there. Denise was just telling me Jurassic Park is coming out in a week, and he's got a whole lot of stuff on dinosaurs. And all the kids' stuff is going to be discounted today. So if you have kids, grandkids, if your neighbor has kids, if you know any kids, you might want to consider looking at what he has that you could purchase for them. So Dr. Lisle told me that he got his undergraduate degree in physics and astronomy with a major in math. So for us mere mortals, just to put that in language we can understand, his degree is in math and math with a minor in math. Since my daughter, who has a degree in French, took an astronomy course, and after the first week intensely regretted it because of all the math. But, you know, somebody has to understand all that, and we're thankful that he does. So he has excellent credentials, and we're privileged to have him here. So we're going to, like I said, we're going to have one session, take a break, and then we'll go on from there. So, Jason, it's all yours.
Start by talking about the worlds of creation. This is about our solar system. And, you know, astronomy is one of those areas where the secularists like to use information about astronomy to try and persuade people that the Bible's not true, and they'll mix in some truth and they'll mix in some error. A lot of astronomy textbooks have some good information in them, and they also have some stories about the past that I would disagree with. Because when you talk about what happened in the past, you're really not doing science at that point. You're speculating on what happened. And that's a little different than in terms of stuff we can repeat and test in the present. And so as an astrophysicist, I'd like to take back astronomy and give it back to the Lord, to whom it belongs. And so I wanted to kind of explore our solar system today and show you how each of these worlds of creation demonstrates the glory of God. In this secular view, our solar system is an accident. It's something that just happened as a nebula, a cloud of hydrogen gas collapsed in on itself. And as this cloud collapsed in, it began to rotate and so on like a skater when she pulls her arms in. And that formed the sun, and that's why it's spinning the way it is, and that's why the planets are all in the same plane, and they all ought to be spinning the same way and so on. But we're going to see that the actual facts of the solar system are not what you'd expect if that secular view were true. The solar system has been deliberately created by an all-powerful God, a God of beauty and a God who has created all kinds of wonderful things in this system. And what a privilege that we live in a time where, via the technology the Lord's allowed us to develop, we have sent craft out into space, and we now have detailed images of all the large objects in our solar system and many of the small ones as well. Something that our ancestors only could have imagined. And using this software, I'm going to show you some of these objects, and what you'll see is accurate. It's based on actual images that have been taken by these spacecraft, and then we've remapped them onto a sphere so we can rotate it around and so on. But this is what you would see if you were there. And I think that's pretty neat, because the one disadvantage of being in the world today is it's easy to make stuff that looks very realistic that isn't. Okay, we live in the kind of the Star Wars age where you can make these beautiful worlds that don't actually exist. What you're going to see here is the actual worlds that God made. Pretty amazing. What you see here is an overhead view of the solar system with the paths of the planets highlighted in green. And this is basically the way the solar system looks today. If you could go above the sun, several million miles above the sun and look down on the solar system, this would be the current positions of the planets as they are today. It's pretty neat we can do that with software because the planets obey laws of physics, and those are math based. And so we can predict where the planets are going to be, and we can show you where they were, because God upholds his universe in a very consistent way for our benefit. So those are the planets there. Their orbits are ellipses. An ellipse is like a circle that's been squashed a little bit, right? But they're just very slightly elliptical. They're almost perfect circles. But you can see that Mercury, for example, Mercury is closer to the sun in its orbit when it's up there, and it's farther away when it's down there. You see that? It's not a perfect circle. It's just a little bit squashed. So in any case, it was Johannes Kepler who discovered that planets orbit the sun in ellipses, not circles, which was believed previously. And of course, Johannes Kepler, he was a biblical creationist. He was a very devout Christian. And he's the guy who said that doing science is like thinking God's thoughts after him, which I think is a great description of it. And he was what we would call today a young earth creationist or a biblical creationist. He computed the age of the earth from the information given in Scripture, and got something like 6,000 years, something like what we'd have today. And so I love that guy. He was a very solid believer and kind of a soft-spoken guy and just somebody to admire. But in any case, he discovered that planets orbit in ellipses. He also discovered the way they orbit the sun, that the planets that are closer to the sun orbit faster and the planets that are farther away orbit slower. He discovered the exact mathematical relationship between those two, between the distance of a planet to the sun and its orbital period. He found that the period squared is proportional to the distance cubed, exactly. And that's pretty neat. He also found the formula that describes the way planets move within their orbit. When planets, because the orbit's elliptical, they're a little closer to the sun sometimes and a little farther away other times. And when they're closer to the sun, they orbit a little faster. And when they're far away, they orbit slower. Okay? And you might be able to see that a little bit with Mercury, because again, the orbits are pretty close to circular, but Mercury's is the most elliptical of the 8 classical planets. And so he discovered that too. He discovered that planets sweep equal areas in equal times. That describes the exact mathematical relationship in terms of the orbit. So those 3 principles, that the planets orbit the sun in ellipses with the sun at one focus of the ellipse, that planets sweep equal areas in equal times, and that the distance cubed is proportional to the period squared. Those are Kepler's 3 laws of planetary motion, and they describe the solar system. Pretty amazing. And you might look at that and say, I don't know, I think eventually I could maybe figure that out, but he didn't have a computer simulation like this, okay? Because you can say, yeah, I can see those are slightly elliptical. He didn't have this. He had a list of numbers of the position of the planets, especially Mars, as it's seen from Earth. Which, if you think about it, that's a complicated problem to solve, right? Because we're on one of these little guys, looking at the other one. So we're moving and they're moving. And so we can only describe their relative position relative to the Earth. So basically he had to solve 2 problems simultaneously, Earth's orbit and another planet at the same time. Pretty brilliant. I hope that gives you a little bit of insight into the genius of this man, and somebody who rightly credited God for these wonderful truths. So these are the inner 4 planets that you see here: Mercury, Venus, Earth, and Mars. The outer planets orbit much further away. I don't think people appreciate how big the solar system is. It's remarkable. And because the period squared is equal to the distance cubed, the planets that are very far away move very slowly. So we have to really speed up time. So see the inner planets whipping around there? Yeah. Jupiter takes about 12 years to orbit the sun once. Saturn takes 29 years to orbit the sun once. Neptune's over 100. So it gives you a little bit of an idea of the nature of the solar system. It's quite wonderful. The planets all orbit in approximately the same plane, and we can see that if we go edge on there. Now, they used to argue that that supports this solar collapse model, because you'd expect that if a nebula collapsed and things are spinning, it'd be like a pancake, and that's kind of what we have. But we're going to see that there are some problems with that model as we explore each of these worlds specifically. A lot of textbooks will present a perspective view of the solar system where it's kind of in between overhead and edge on, and that sometimes people get the false impression that that's overhead and the orbits are really squashed. They're not. They're very slightly squashed. And so if you look at an overhead view, it'd be hard to distinguish most of those from a perfect circle. The only one I can see by eye would be Mercury and maybe Mars. If we go back into the inner planets that you see there. So there we go. Mercury whips around there. It takes 88 days for Mercury to orbit the sun once, so it's the fastest. Earth, 1 year. That's where we get the idea of a year. And Mars about 1.5 years, and so on. You can see that Mars comes closer to the Earth at some points than it does at other points. So right there, and they're farther away there. Okay. So the sun is at the center of our solar system, and it is 99.98% of the mass of the solar system. Okay? The planets, the moons, and everything, that's the little percentage that's left over. The sun is most of the mass of the solar system. It is huge. The sun is a ball of hydrogen gas. That's the lightest element, but there's a lot of it. There's a lot of it. The sun is about 100 times the diameter of the Earth, to give you a feel for it. And if it looks small, that's because it's 93 million miles away. So the fact that you can still see size to it is remarkable. It just gives you a feel for how big it is. So that's what the sun looks like, something like that. And it is, again, a ball of hydrogen gas that's held together by its own gravity. A lot of people ask, why doesn't that gas disperse into space? Gravity holds it together. Yes, gas has gravity. Everything does. Everything that has mass has gravity. And if you have enough, so you have your own personal gravitational field. It's just very, very small because you don't have a lot of mass. But the sun has a lot of mass, so it's got a lot of gravity. So there you go. And you can see there are spots on the sun, which astronomers call sunspots. Those are cooler regions on the sun. The sun's surface temperature is about 6,000 degrees Celsius, whereas those sunspots are a chilly 4,000 degrees Celsius. So they're not as bright. Actually, they are luminous. If you could separate them from the sun, they'd be bright. But because they're cooler, they give off less light and they appear dark by contrast. And those are places where the magnetic field of the sun is very complicated. It's much more so than the Earth's. The sun has a north and south pole like the Earth does, but except they flip the sun's magnetic field flips every 11 years. And it also has east-west magnetic fields, kind of form a complete loop in the northern hemisphere and in the southern hemisphere of the sun. And those move every 11 years. They kind of collide at the equator and neutralize each other. The sunspots are where those toroidal magnetic fields poke through the surface, and magnetic fields inhibit motion of plasma, which is what the surface of the sun is, basically ionized gas, and that causes them to cool off. So there's always a strong magnetic field associated with a sunspot. The sun itself is fascinating. You think, well, it's a ball of gas, but it's surprisingly complex for a ball of gas in terms of the way that it rotates and so on. It rotates differentially, so the equator rotates faster than the poles, so it's constantly twisting, but it can do that because it's a ball of gas, okay? So the equator takes 25 days to rotate once. The poles take 33. So it's kind of interesting. And it's fusing hydrogen in the core and basically a nuclear bomb, but at a very steady rate and in a way that's safe because there's all kinds of material around it to absorb any particles that would be too energetic for human beings and so on. And the sun produces more energy in 1 second than 1 billion cities on Earth could use in an entire year. Wow. Just incredible. And it gives you a little taste of the power of God. Just a little taste of it. So there's the sun. And we've sent spacecraft past all the planets in our solar system. And so let's take a look at what we see when we, for example, went to Mercury. We sent a spacecraft to Mercury in the 1970s, the Mariner 10 spacecraft. And we sent another one more recently, the Messenger spacecraft. And that's what Mercury looks like. It looks kind of like the moon, really. But it's a planet because it orbits the sun directly. It's a little bigger than the moon. But it has that heavily cratered surface. There's not much of an atmosphere on Mercury, so you couldn't breathe. That would be a problem. Mercury rotates very slowly. It's interesting because it orbits fast. It's got the fastest orbit, but it's got a very slow rotation. That's kind of interesting. And because it rotates very slowly, and because it has no atmosphere, and because it's 3 times closer to the sun than Earth is, that day side gets baked, and it reaches temperatures of 800 degrees Fahrenheit. Yeah. Meanwhile, the night side hasn't seen the sun for perhaps a couple of months because it rotates so slowly. And so the night side just cools off. It radiates that heat into space, and so it drops to negative a couple hundred degrees Fahrenheit. And so it's a planet of extremes. It really is. And since the day side is baking hot and the night side is freezing, it follows that there must be a spot somewhere around there where it's kind of nice, right? So if you crash land on Mercury, you want to aim for right about there. So a little bit after sunset, right? And the interesting thing is because Mercury rotates so slowly, if you crash land, just a little bit after sunset, and you started running west, you could outrun sunrise. So you could maintain that comfortable temperature, but you have to keep going west, okay? And you can actually outrun sunrise, which is kind of weird to think about that, but that's how slowly it rotates. One of the really interesting things about Mercury is it has a magnetic field like the Earth's. It's not as strong as the Earth's, but it's there. So it's got a north and south magnetic pole. A compass would work on Mercury, okay? And you say, well, why is that interesting? Because in the secular view, that shouldn't be. You see, Mercury is only a third the size of the Earth, and magnetic fields are caused by electrical current in a planet's core. So the Earth has one, and the problem with that is magnetic fields decay with time because that electrical current encounters resistance, and so they fade. It's an exponential decay. They get weaker and weaker. We can measure that on the Earth. It gets a little bit weaker every year. Okay, now with Mercury, in the secular view, this planet's supposed to be 4.5 billion years old. But if it were that old, the magnetic field would have decayed away a long time ago. It should be gone. It should not be there. And so it was really surprising for the secularists to find that it has a magnetic field that's still decaying. And there's some evidence that even between the decades where we sent those 2 spacecraft, it's actually decayed noticeably in those decades. So there's no way it's billions of years old. See, the Earth's a bigger planet. And so the secularists can argue, well, maybe with the Earth, although I think there's problems with that too. But with Mercury, it's little. You know how little batteries, they don't last as long. Remember those big D batteries, which you don't use them hardly anymore, but they last a long time. The little AAAs, they don't last very long. Mercury's like a little AAA, but it's still got a lot of charge. That tells you it hasn't been in existence very long. A few thousand years? Yes. Billions of years? No way. It's a problem. And that cratered surface reminds us of what the Earth would look like if we didn't have that protective atmosphere that the Lord gave us on this planet. Because everything that comes close to Mercury, boom, it impacts on the surface because there's no atmosphere to protect it. And so that tortured surface is kind of what the Earth would look like if we didn't have those special features that the Lord placed on our planet. Now the next planet out is Venus. And Venus is an interesting world. It's sometimes called Earth's sister planet because it's the same size as the Earth. But frankly, that's where the similarity ends. They're quite a bit of different. And it is the same. It is about the same size. It's just slightly smaller. 95% the size of the Earth in diameter. So that's what it looks like. And a number of interesting things about Venus. For one thing, it rotates backwards. And that is really shocking in the secular view because if all the planets formed from a collapsing cloud, conservation of angular momentum ought to cause them to all be spinning about the same speed and in the same direction. And Venus is just exactly the opposite. Just exactly backwards. Almost as if God did that just to confuse the secularists. But it's kind of interesting. It's got a very thick atmosphere. It's 100 times thicker than Earth's atmosphere. Okay, so it's just incredible. The pressure would be crushing at the surface. And it has clouds that permanently enshroud the planet. That's what you're seeing there. It's not the surface, that's the clouds. And because of that, we didn't know what the surface looked like for a long time. You can never see the surface in a telescope from the Earth. You just see those reflective clouds. And they're very bright because it's close to the sun anyway. And then the clouds are very reflective. So it's very pretty to look at in a telescope, but you never see the surface. And there were in the past some secularists that thought that life might have evolved on Venus too. And it might have all kinds of exotic life forms on its surface because it's a little closer to the sun. It might be a tropical paradise with all kinds of interesting creatures. And you'll see that in the older science fiction movies. There was an Outer Limits where William Shatner gets to land on Venus, and there are these creatures, and it's all eerie because it's in black and white, and that just makes it creepier somehow. Anyway, that was before they discovered that the surface temperature is 900 degrees Fahrenheit. Yeah. See, that thick atmosphere traps heat. It creates a greenhouse effect, a very substantial greenhouse effect, because it's got an atmosphere that's 100 times that of Earth. So that's substantial. It actually makes it hotter than Mercury. Remember, Mercury is only 800 degrees on the surface. Venus is further away, but it's hotter because of that thick atmosphere. And then some people say, well, see, that's why we got to reduce our carbon footprint on Earth, because we'll end up like Venus. No. First of all, carbon dioxide is a mild greenhouse gas. And secondly, the atmosphere is 100 times thicker than the Earth. You can't do that on the Earth, okay, because we don't have the kind of atmosphere to sustain that level of greenhouse heat. Now, the neat thing is, because with modern technology, we've actually sent some spacecraft past Venus. One of them orbited, the Magellan spacecraft orbited Venus, and it used radar. Now, the neat thing about radar is it can go through clouds. And so we know what the surface looks like now. And it looks like that. That's the surface of Venus. Sometimes you've seen images that looks like that, and sometimes even in certain magazines and something. That's not what you'd see, right? That's what you'd see if you could remove the atmosphere. That's a radar map. But you never actually see that because it's enshrouded in those thick clouds. So there it is. That's the surface of Venus. Beautiful planet. But not a place I'd want to visit. Not with 900 degree Fahrenheit surface and an atmospheric pressure that would crush you like a tin can. And those clouds are made of sulfuric acid. So there's just lots of ways to die on Venus. It's just... And then some people say, well, why did God make a planet like that with, a toxic atmosphere that you can't breathe and it would crush you or bake you or dissolve you in acid? Well, you're not supposed to go there, right? He didn't make it as a vacation spot. That atmosphere makes Venus very reflective and very beautiful. And so it is, it's the third brightest object in Earth's sky. You got sun, moon, Venus. It's very pretty. You sometimes see it in the west in the evening after sunset, or in the east in the morning before sunrise, if you're a morning person, which I'm not. So there you go, Mercury and Venus. Now the next planet out, Earth, my very favorite. All my friends live there. All your friends live there. It's got the most restaurants of any planet. And a lot of unique features that make the Earth designed for life. It has free oxygen in the atmosphere, which is relatively rare. Oxygen is usually bound up in other chemicals, but we need that to breathe. So of course that would have to be the case. Liquid water on its surface, liquid water covering 71% of the planet. Now the water molecule is pretty common in space, but it's usually either ice or vapor. To have liquid water, you have to have the right temperature and the right air pressure. And of course, Earth has just the right temperature and it has the right air pressure to have liquid water on its surface. And of course, liquid water we think is necessary for life. All the life that God created, as far as we know, requires water in order to exist. And so the planet that God formed to be inhabited, the Bible says that in Isaiah 45:18, God formed the earth to be inhabited. It has all those features that make it right for life. The right kind of atmosphere, the right distance from the sun, liquid water. It's got a magnetic field that protects us from cosmic radiation. Out in space, you get dosed with cosmic rays, and they can damage your DNA and give you things like cancer. Not good. That's why the astronauts have to be a little bit careful. They have to, when they're out in space. Of course, the International Space Station is mostly within Earth's magnetic field, so they get protection. They get some protection there. But ideally designed for life. It has plate tectonics. Yes, the Earth is divided. The crust's divided into plates. And we think that that's what God used to initiate and also to end the worldwide flood. So plate tectonics would be the mechanism. So we think the continents were probably connected before the flood, and then they were pushed apart during the flood, and that caused it. And also, as they drifted into their final positions, they kind of bobbed back up and so on. There's Dr. John Baumgartner has a wonderful computer simulation that demonstrates how this could have happened. In any case, it's interesting. And as far as we know, the Earth's the only planet with plate tectonics. Other planets have tectonics, geologic activity, but they are not divided into plates that are movable. And so it's kind of interesting. The one planet that God knew he would need to flood, he made it floodable. He designed it that way. And he knew that would happen, of course, because he's God, he's beyond time. The Earth is tilted about 23.5 degrees. That's a design feature. That's what gives us seasons. But it also makes the Earth more habitable. if you detilted the Earth, which is what you would expect if the solar system had collapsed from a nebula, all the planets ought to be upright. They really they shouldn't be tilted like that. And if it were upright, there would be no seasons, but that would reduce the habitable zones of the Earth. The equator would be too hot, the poles would be colder than they are now. It would reduce the latitudes at which you can have life. On the other hand, if the Earth were tilted more, the seasons would become extreme. And so the summers would be too hot for life, the winters would be too cold for life. So it's tilted about the right amount for life to exist and to be sort of optimized. So lots of wonderful features on the Earth that make it right for life. The Earth has a moon, which we call the moon. You understand what, 5,600 years of Earth's history, this was the only moon we knew of. Nobody thought that other planets could have moons. That's a new idea. That didn't happen until 1610, when Galileo was the first to take a telescope and point it up at Jupiter, and he saw that it had 4 little stars next to it that orbited around Jupiter. So Jupiter has moons too. But before that, we just knew of Earth's moon, and it looks like that. It looks kind of like Mercury. It has these large dark features called maria. That's Latin for seas, because they used to think they were actually seas, oceans. They're not. They're basalt. That's like a magma type rock, a volcanic rock that forms from magma. So there's the moon. It goes through phases. That just depends on where the sun is relative to the moon and our line of sight. So the sun would be to the right side when you see it in that phase, and then the sun's kind of back behind us when you see it full, and so on. So those are the phases that the moon goes through. Now the moon rotates, and yet we see the same side of it because it rotates at the same rate it revolves around the Earth. It's called tidally locked. That's a very energetically favorable position. All large moons do that. They keep their same face pointed toward their planet. And but people think it doesn't rotate. No, it does rotate. If it didn't, you would eventually see all the sides of it, right? It just rotates at the same rate that it revolves around the Earth. And so if we watch it from space, you can see it rotating, and then the Earth will be in the background here in a moment, because the one side of the moon does always face the Earth. There's the Earth. Let me rotate it around here a little bit. Okay? And there were 12 people who got to walk on that. And I always thought that was amazing, that they could look up and see the Earth, this little gem, little blue, beautiful marble, and just think everyone that they know is on that world except for the one person next to them and the one person in the orbiter. Pretty amazing. And we're scheduled to go back to the moon. I hope that happens. I'd like to see that. So, pretty amazing. And what a privilege, too, that we live in a time where we have seen the Earth from above. Just wonderful. And it's so beautiful. It's so beautiful. Who could have imagined that it would be that beautiful? So the moon, by the way, is spiraling away from the Earth due to tidal forces. And that's something that if you run it backwards, and you have to do the math right, because it's not a linear rate. It actually speeds up as you go back in time. You find that the Earth and moon would have been in the same place at the same time 1.45 billion years in a hypothetical past. You say, why is that a problem? Because they're supposed to be 4.5 billion years old. You see, both the Earth and the moon. But they can't be older than 1.4 billion years because they can't get closer than 0, right? So, but if the Earth's about 6,000 years old, as the Bible implies, then the moon would have been 751 feet closer at creation. Not a big deal, considering it's 240,000 miles away. So there are all kinds of indications that the Earth is not billions of years old, including its decaying magnetic field. We've been able to measure the Earth's magnetic field decay over the centuries. You run it back in time at creation, about 6,000 years ago, it would have been 20 times stronger than it is today, which would be nice. Increased protection from cosmic rays and so on. You run it back 60,000 years, not 6,000, but 60,000, the magnetic field will be stronger than a neutron star, which is enough to rip the iron out of your blood. So it can't be anywhere near even 1 million years old, let alone billions. So I think that's pretty compelling. So next out we have Mars, the red planet, because it's red. It's made up of iron compounds that are combined with oxygen, basically rust. The reason rust looks red is it's got a similar composition to Mars. And Mars, although it's only half the size of the Earth, it's probably the most Earth-like planet in all other respects. It has some unique features on it, but it has some very Earth-like features on it as well, including canyons and valleys. You see that large down there at the bottom? That's called Hellas. That's an enormous valley. Sometimes fills in with fog and looks very bright in a telescope. People mistake it for the southern polar cap, but it isn't. It's close though. It has canyons. You see that large, looks like a huge scratch right there. That's the Valles Marineris Canyon. It dwarfs Earth's Grand Canyon. Earth's Grand Canyon is impressive. This is really impressive. In fact, the length of that's about the length of the United States. So it's massive. It's deeper, wider than the Grand Canyon. It's not a water canyon, however, because the water would have to go up to get out. It's closed on all ends. So we think it's a tectonic fissure where the crust has sort of broken open there. You see those large features there, these three, and then that one right there? Those are mountains, volcanoes in fact, and they're enormous. The fact you can see them from space tells you those are enormous. This one right here is called Olympus Mons. It's the largest known volcano. It's 3 times taller than Mount Everest. And the base of it would cover the entire state of Iowa. So it's massive. It's kind of shallow sloping. It's what we call a shield volcano. So, you know, features that the Earth has, just they're bigger on Mars. It has less gravity. If gravity's weaker, things can get bigger. It has polar ice caps. There's the northern polar ice cap. And like Earth's ice caps, the northern ice cap shrinks in the summer, and then it expands in the winter, just like Earth's ice caps do. But Earth's ice caps are made of liquid, or basically water, frozen water, and then Mars's ice caps are mostly carbon dioxide, frozen carbon dioxide. So the substance is different, with some frozen water too. Mars doesn't have a drop of liquid water on the surface as far as we know, and yet there is evidence that at times it has had water on its surface because we find dried up riverbeds and deltas. There's compelling evidence Mars had water in the past. We think that may happen when volcanoes go off. On Earth, volcanoes spit out a lot of water. We think they might do that on Mars too. And that temporarily increases the atmospheric pressure to where you can have liquid water. But normally the atmosphere is too thin to have liquid water. It just boils away. It's kind of like dry ice on Earth. Okay, you can't have it in a liquid state. It goes immediately from solid to gas. So there you go. Mars has what's called remnant magnetism. And that means there's little bits of magnetic field all over the surface, but it doesn't have a dipole magnetic field. So you would not get protection from cosmic rays on Mars. That's going to be a problem if people ever want to colonize Mars. Elon Musk wants to go there, and more power to him, but I don't know how he's going to deal with the radiation problem. That's an issue. Very thin atmosphere on Mars of carbon dioxide, which you cannot breathe. So you'd have to bring a little bit of Earth with you to survive there for any bit of time. You'd have to bring some oxygen and some food from the Earth and some water, although you might be able to extract water from the water vapor in the atmosphere. But yeah. So similarities and differences. One of the similarities is the rotation rate is similar to Earth. Earth's 24 hours, right, from sunrise to sunrise. Mars is 24 hours and 36 minutes. Rotates just a little slower than the Earth. You get an extra half an hour every day, which I think is neat. You could sleep in an extra half an hour every day. It would never catch up with you. So that's kind of neat. I could do that. So there you go. It has 2 moons, and they are tiny. They're called Phobos and Deimos. The names mean fear and terror. Mars is supposed to be the god of war, and fear and terror accompany war, right? There's Deimos, itty bitty little moon, about 10 miles across, and not quite round. That surprises people. But only large moons are round. Small moons can have kind of a random shape because there's not enough gravity to pull them into a spherical shape. So I think it looks kind of like a potato. So there's little Deimos. Again, 10 miles across. So you could walk around that world, and it would be a nice little hike. Walk all the way around it. Deimos. So Phobos is the inner of the two. It orbits remarkably close to Mars. So there's Phobos. Okay. Just a little bigger than Deimos, a little more than 10 miles across, depending on which axis you pick, because it's not round. So you can't really talk about a proper radius or anything like that. It has an enormous crater on one side that probably, whatever did that, probably came close to breaking it apart. And the view would be spectacular if you're on the Mars side of Phobos. If you're not, it's a short hike to get there, because again, it's only a few miles across. So the view would be spectacular. You can imagine looking up at Mars and seeing it like that in the sky. It would be spectacular. The gravity on Phobos is very weak because there's not much of it. And so you could jump really high. You could almost jump off. You could certainly pick up a rock and throw it into orbit, watch it go down over the horizon, and catch it as it comes up over the other one. Kind of interesting, isn't it? So it's kind of weird to think about these situations that really can occur on the Earth. So there you go, the red planet. Pretty neat. We've sent a number of spacecraft there, and it's fun to look at the pictures that we get back from those. Quite remarkable. So those 4 planets, Mercury, Venus, Earth, and Mars, that's where they are today, those are called terrestrial, meaning Earth-like. You could land on them. You could walk around a little bit. You'd have to have, for all but the Earth, you'd have to have a spacesuit, right? For Venus, you wouldn't last very long, right? But the other ones, you could theoretically walk around a little bit. They're solid. The outer planets are not. And we'll start with Jupiter. Jupiter is not terrestrial. It's what we call a Jovian planet, which means Jupiter-like. It's a ball of gas, like the sun. Same gas as the sun, although it has some other compounds too. It has ammonia and methane in it, and that's what gives rise to those wonderful colors that you see. But it's a ball of gas held together by its own gravity. It rotates very quickly. It takes only 10 hours for Jupiter to rotate once. And that actually, and because it's massive, it's 10 times the size of the Earth in diameter. And that causes the equator to bulge out a bit. And it's noticeable. In a small telescope, you can see Jupiter's not perfectly round. It's a little bit squashed because it rotates so rapidly. And so you can see that there. You can always notice, almost always, those 2 stripes that you see there. Jupiter is divided into what we call belts and zones. The belts are dark, the zones are light. So you have the 2 equatorial belts surrounding the equator. And you can see those in a small telescope, almost always. You can see at least the 2. And then there are other ones that are smaller that you may or may not be able to see in a small telescope, depending on how good conditions are and how good your telescope is. But they're there. And those are just clouds that have been stretched out. You might know Earth has jet streams, right? And we've got a polar one, we've got a mid-latitude one, we've got an equatorial one, and then in the southern hemisphere. Jupiter's a bigger planet, so it has more jet streams. Okay, but that's what they are. And it's just that Jupiter's clouds are very colorful. You got the orange ones made up of methane type compounds, and then the white ones would probably be ice, water type stuff in Jupiter's atmosphere. So there you go. It's a beautiful planet. It's fun to look at in a small telescope. And you can watch the various features on it. One of the most noticeable features is this great red spot, which astronomers call the Great Red Spot. That's an enormous cyclone or anti-cyclone because it's a high pressure system. And so a big storm, think of like a big hurricane. And it's big enough you could put 2 Earths in it. Now hurricanes on Earth, they're powered by the ocean. They get the ocean temperature. After a hurricane, the ocean temperature drops 10 degrees. Okay, so that's what powers it, is heat. And then the hurricane moves over land. It gets cut off from its power source and it peters out. On Jupiter, there's no land. So that hurricane has been going on for a long time. We've known it's there for at least 300 years. And now it moves forward and backward. It can't move up and down because it's sandwiched in between the southern equatorial belt and the zone that's just below it. They keep it constrained in latitude, but it can move forward and backward a little bit. There are websites that'll tell you when the red spot's going to be centered, and that's the best time to see it in a small telescope, if you want to try to look at that. It's been shrinking the last few decades, so we don't know if it's permanent or if it'll go away after a while. We don't really know. But it's pretty, for a storm, 300 years, that's pretty good. And it might have been there since creation for all we know. We don't really know the answer to that. Jupiter has an enormously powerful magnetic field. So it's so powerful you can actually get aurora borealis and aurora australis, northern lights and southern lights. That's what you're seeing there in that image. And that's radiation from the sun impacting the magnetic field, jiggling it, and causing the particles to emit radiation, emit light. So, and it's quite beautiful. So that tells you that Jupiter has an incredibly powerful magnetic field, and that should not be the case if it's billions of years old. That magnetic field should have decayed away a long time ago. I don't know if you can see it or not, but Jupiter does have a thin ring system like Saturn. It's just much thinner and very difficult to see except under certain circumstances. But those are trillions of tiny little particles of rock and ice that are orbiting around Jupiter. So pretty amazing. Jupiter has internal heat. That means it's warmer than it should be if it were billions of years old, because it's radiating that heat out into space, and it can't do that for billions of years or it'd be cold by now. It'd be an icicle. It's kind of like a potato that you've taken out of the microwave. You can feel the heat coming off of it, right? But if you come back 2 hours, you can still feel the heat coming off of it? No, it's cold. It's radiated its heat away. Now, Jupiter's a much bigger potato, and so it can do that for thousands of years, but it can't do it for billions of years, or it would be cold by now, okay? So the magnetic field and the internal heat of Jupiter are both indications that the biblical time scale is right, the secular time scale is way off, way wrong. Jupiter has a number of moons that orbit it. Jupiter was the first planet where we discovered moons, and that was discovered by Galileo in 1610. He saw 4. There are actually more than that, but there are 4 big ones. And the innermost is called Io, or Io, and I love Io. It is the coolest looking moon. It just looks so weird, like an orange that you forgot you left in the refrigerator. Isn't that wild? Nothing looks like this. It is totally unique in the solar system. And those little pock marks you see all over there, there are no impact craters on Io. Interesting. There's passing behind Jupiter. That's a little lunar eclipse there. So those little pock marks that you see there are volcanoes. And they are quite active. When Voyager 2 flew past Io in I guess it was around 1980 or so, it discovered 9 volcanoes going off simultaneously. It's very volcanically active. That indicates a lot of internal heat. Some of that might be generated by tidal forcing between Jupiter and Europa, but it could just be left over from creation, which would indicate that Io is nowhere near billions of years old. It's a few thousand years old. So it's a beautiful little moon, one of the most colorful moons in the solar system. It kind of makes me feel like we got ripped off on our moon, because ours is very gray. But and the colors are due to sulfuric compounds. If you've ever been to the Yellowstone Park, the geyser area, it looks similar to that because of the sulfur compounds. It's similar chemistry. So there you go. You notice it keeps the same face pointed toward Jupiter. All large moons do that, including ours. It'll occasionally cast its shadow on Jupiter. You see that? That little black spot there on Jupiter above the red spot? That's the shadow of Io. And you can see that in a small telescope, and it's predictable when that'll happen. So you can point your telescope there and look at that. It's really cool. So there's Io. It's about the same. Io is about the same size as Earth's moon. Europa just a little smaller, and Europa is known for having these large scratch marks on the surface, like a cosmic cat came and just kind of swiped it. See that? Isn't that interesting? We think those are perhaps geysers, where the surface is broken apart and geysers have ejected out. That requires heat. Heat can't last billions of years, so that's an indication that that Europa is young and nowhere near billions of years old. The next moon out is Ganymede. Ganymede's the largest moon in the solar system. It's actually bigger than the planet Mercury, but because it orbits a planet, it's a moon. If it orbited the sun directly, it would be a planet. So there's Ganymede. It's about 50% larger than Earth's moon, a little bigger than Mercury, and quite beautiful, I think. It's got kind of a tritone color. It's got a dark brown, a lighter brown, and a white that is very beautiful. Isn't that lovely? And again, this is what it looks like. This is what it would look like if you were there, because we know that because we've taken pictures of it from different angles, and so we can reconstruct the surface, and that's what it looks like. Beautiful moon. The largest moon, and it orbits the largest planet, so it makes that easy to remember. And then the outermost of the big 4 is Callisto. These are the 4 moons that Galileo discovered in 1610. There's Callisto, just slightly smaller than Ganymede, pockmarked with little craters all over the surface, probably impact craters. So, isn't that delightful? So those 4 moons, they're sometimes called the Galilean satellites because they were discovered by Galileo in 1610. And they were the first moons discovered orbiting another planet. They didn't even know what to call them at first. They called them planets initially because nobody thought that a planet could have moons other than the Earth. That was unique. So there you go. We now know that Jupiter has a bunch of smaller moons too. And it's interesting. The inner moons, that's not what I wanted to do. This is what I wanted to do. There we go. So there's 4 interior to Io. They're small though, and they have random shape like Phobos and Deimos orbiting Mars. And then there are moons that orbit beyond Callisto. Now the inner moons all orbit in the same direction and in the same plane. And the secularists like that because that's what it would have to be if it formed from a cloud. But it's actually a design feature. You see, being all in the same plane and orbiting the same way prevents collisions. There's organization there because there's not a lot of space available because you're close to Jupiter. Okay, so that's a design feature. But the outer moons are not so constrained. There's plenty of space available. And if we speed up time, you can see the outer moons, a lot of them orbit backwards, so they can orbit in different directions. And they're not even in the same plane. If we look at the system edge on, the inner moons all are in the same plane. The outer moons, they just kind of do what they want. And that's a common feature of planets and moons within our solar system. And it's a design feature because there's plenty of space available out there. And so it may look very crowded because the lines are thick, but those moons are millions of miles away from each other. And so there's no chance of collision. They never come close. Their orbits are perfectly well defined. They're perfect ellipses. It's just each one is different. And so it looks crazy, but it's actually very organized. So that's the Jupiter system. A lot of fun to look at. Jupiter has, I think, 79 moons at latest count. So, yeah. And we keep discovering new ones. Saturn, however, currently holds the record of most moons. It's got 82 at the moment. Again, they keep discovering more. Most of them are tiny, but a few are a little bigger. So there's Saturn, everybody's favorite, right? Because it's got that beautiful ring system. Saturn's about 9 Earths across, so it's just a little smaller than Jupiter, made of gas like Jupiter, hydrogen and helium, held together by its own gravity, right? And Saturn has a magnetic field like Jupiter. That means it can't be billions of years old. The magnetic field would be gone by now. It would have decayed away. And of course, those beautiful rings, those are trillions of tiny little moonlets, particles, dust, ice, some rock perhaps, that are orbiting around Saturn's equator. And it's wonderful. The Lord tilted that planet substantially so that we can see the rings. But you see, if the secularists are right, it shouldn't be tilted that way. It should be upright due to conservation of angular momentum. If all the planets formed from that collapsing cloud, they ought to be spinning, they ought to be upright. And that would be a shame because you'd never know it had rings. When they're edge on, you can't see them because they're very thin. You can still see the shadow there because it's tilted relative to the sun, but if it were not tilted relative to the sun or the earth, you would never know it had rings until you went there, and then it'd be kind of a surprise. There's a famous picture of Saturn that's Saturn in a crescent phase, and I don't think people realize the significance of that. You cannot see the outer planets in a crescent phase from Earth because you have to be farther away from the sun than the planet to see a planet in a crescent phase, right? So this is proof that we've been there. We actually have sent probes out past Saturn, and so we have images of it from behind, and that's remarkable. It's just neat that we can do those kind of things with our technology these days. So Saturn it's a wonderful planet. It's beautiful. It's fun to look at in a small telescope. Yes, you can see the rings. They're spectacular. There are gaps in the rings. You might notice that. That's due to moons that orbit outside the rings, but their gravitational influence causes a resonance and pulls the particles out of certain gaps there. One of them is caused by Mimas. Mimas is one of the innermost moons of Saturn. Let's zoom in on Mimas here. There's Mimas. And it has this massive crater. You can see it right there. And from certain angles, when the sunlight hits it just right, it looks just like the Death Star from the Star Wars movies. It's quite remarkable. So we'd like to think of that as Darth Crater. It's actually called Herschel, but Darth Crater's a good nickname for it. There's a number of different moons around Saturn, but I think, let's see what number 4 is here. Oh, it's Dione, okay. And a lot of these look a little similar to our moon in terms of, kind of grayish and fairly heavily cratered. Here's Tethys. Tethys is quite bright, and it's easy to see in a small telescope. There's Tethys. I was trying to get Enceladus. I guess that's number 2. Yeah, Enceladus. Enceladus is interesting because it's got these streaks on its surface, a lot like Europa. And in the case of Enceladus, we know what these are. We know they're geysers because we've caught them going off. So you see those streaks there? They look a little bit bluish. So that indicates that Enceladus has internal heat that causes the water to heat up and it blasts it out as water vapor into space. And we've caught it doing that. And yet this moon is over 100 miles in diameter, so it's small compared to our moon. It's pretty small. It's big enough to be round, but not that big. And the fact that it still has internal heat indicates it can't be anywhere near millions, let alone billions of years old. So again, we find all kinds of indications of youth in our solar system. The biblical time scale is right, the secular time scale is wrong. That's all there is to it. One of the most famous moons of Saturn is called Titan. It's the second largest moon, which is fitting because it's orbiting the second largest planet. Makes that easy to remember. There's Titan, and it is weird because it's orange. And that's because it has a thick atmosphere, which is rare. Titan's the only moon we know of that has a thick atmosphere. And it's an atmosphere of hydrocarbons. What are hydrocarbons? Things like gasoline are hydrocarbons. So gasoline would be really cheap on Titan because that's kind of what it's made of, right? On the other hand, oxygen would be expensive, so count your blessings. So there you go. So there's Titan, that thick atmosphere. And you can always see Titan as this little orange star next to Saturn. You can see it in a small telescope, maybe binoculars if you got good vision. So yeah. And again, for centuries, we didn't know what the surface looked like. Because again, that thick atmosphere of hydrocarbons. And, but now we've sent spacecraft there, and using radar, we can penetrate those clouds, and so we know the surface looks like that. That's the surface of Titan. You see Saturn in the background there. So, and Titan actually has, it's one of the few worlds that has liquid on its surface, but it's not liquid water, it's liquid methane. Liquid methane. So it has seas of methane. We know that now. So it's quite remarkable. And that was astonishing to the secularists. They were expecting ethane instead of methane. You say, what's the difference? Methane is destroyed by ultraviolet light. And so Titan's atmosphere has a lot of this methane in it. Some of it has been destroyed and converted into tholins, which is what gives it the orange color. But there's a lot of methane on Titan. And if it were billions of years old, the ultraviolet light from the sun should have totally destroyed it by now. It should be gone. And so this is really surprising that it's basically still got tons of methane on its surface. Very perplexing to the secularists. It's exactly what I would expect as a biblical creationist. So there you go. Another moon of Saturn that's really interesting, it's a little farther out than Titan. It's called Iapetus. And Iapetus is interesting because when it was discovered, they found that you could see it when it was on the right side of Saturn, but you couldn't see it when it was on the left side of Saturn. And that was a bit of a mystery. And then it occurred to somebody that Iapetus probably is tidally locked like our moon, so it keeps the same face pointed towards Saturn at all times, which means when it's on the right side of Saturn, you see one side of it. When it's on the other side, you're seeing the other side of it. What if one side is a lot brighter than the other? And it turns out we know that's the case now because we've sent spacecraft past it. One side is dark as charcoal and the other side is white as snow. Isn't that fascinating? And we think we know the reason for it too. There's the leading hemisphere is the dark one, and we think it's collecting material from another moon that's out there that's ejecting that dark material that collects on its surface. But isn't that lovely? Iapetus is interesting, and it's got a mountain range too, right down the equator, just exactly on the equator. And you can see that on the dark side there. Especially right here. Those are mountains, and they're right along the equator. I always thought that was an artifact, but it's true. Isn't that nice? Iapetus. So let's go back to Saturn here. Again, the inner moons all orbit in the same direction and in the same plane. Nice and organized. That's a design feature. The outer moons, they just do what they want. And again, Saturn has over, I believe 82 moons is the latest count. So there you go. Pretty neat. A lot of those are recent discoveries, like Jupiter's 79 moons. When I was a kid, it had 16. And I used to know all their names, but I can't keep up now. Now, in the 1980s, a wonderful thing happened. The outer planets, Jupiter, Saturn, Uranus, and Neptune, lined up in a giant arc. And right at the time where technology was developing to where we could send spacecraft past Jupiter. And since it was in a nice arc, we used its gravity to slingshot it onto Saturn, which we would use it to slingshot onto Uranus, which would slingshot it onto Neptune. Voyager 2 was able to visit 4 planets because God was gracious enough to have the planets line up just in the right order at the right time that technology developed to do that. And that doesn't happen very often, by the way, where the planets line up in that arc. So that's why we have these wonderful images of Uranus and Neptune. We wouldn't have been able to go there otherwise. So Uranus is about 4 times the size of the Earth, has a strong magnetic field, which cannot last billions of years. So that indicates that it's nowhere near billions of years old. It's consistent with the biblical timescale. Pretty featureless. Sometimes you get these beautiful white clouds that form in its atmosphere. The blue's colored by the Rayleigh scattering from the methane. And so it's kind of the same reason our sky's blue. But it's a beautiful world. 4 times the size of the Earth. And it happened to be a sunny day when Voyager 2 flew past. There were very few clouds, and so it looks rather featureless. It has a number of moons. We'll just do one of them for time's sake, Miranda. The big 5 are Miranda, Ariel, Umbriel, Titania, and Oberon. There's Miranda. And it's got a cracked surface. It looks like something happened there, like it's been broken apart and reassembled. So it's interesting. Uranus rotates on its side. Now again, the planets are supposed to all be like that, right? Earth's like that, Mars is like that. Jupiter's is upright, Saturn's is tilted, Uranus is tilted 96 degrees. Again, it's as if God did that just to confuse the secularists. So it's not consistent with the secular idea. Next out we have Neptune, which Voyager 2 flew past in 1989. By the way, Dr. Russ Humphreys, who's a physicist and a creationist like myself, he predicted the magnetic fields of Uranus and Neptune before they were measured by Voyager based on their biblical age of 6,000 years. He was right on. Secularists were way off. You want to do science right, start with the Bible. Neptune has a big dark spot on it, like Jupiter. We thought Jupiter was unique, and then we said, oh, I guess that happens other worlds too. It's a cyclone, low pressure system. It comes and goes, unlike Jupiter's, which is stable. It comes and goes, and sometimes there's another one that forms in the northern hemisphere. We know that from Hubble. Hubble can do almost as good as Voyager 2 could when it was there. Neptune, again, has a strong magnetic field consistent with its biblical age of a few thousand years, and it has internal heat. It gives off 2.6 times as much energy as it gets from the sun. And it's been doing that every day, every second of every day since creation. And it hasn't run down because it's been doing it for a few thousand years. Lots of moons. One of the most interesting is Triton, which orbits Neptune backwards. It's the only large moon that orbits its planet backwards. And again, I think God did that just to confuse the secularists, keep them on their toes. And it has these dark streaks. You see those dark streaks there? We know what those are now. Those are geysers. And they actually spurt up soot into a very thin atmosphere, and then it's got wind that carries them, and it deposits that soot and makes these horizontal streaks. Isn't that fascinating? And that indicates that it's got internal heat, which means it can't be billions of years old. So, because it's considerably smaller than Earth's moon. There you go. So Triton, not to be confused with Titan, which orbits Saturn. And then in around 2004, 2005, Pluto was reclassified as a dwarf planet because, well, for a number of reasons, but it's much smaller than all the other planets. And there are other objects that are nearly as big as Pluto. And so they said, well, maybe it's time to rethink our classification system. Fortunately, in 2015, we got a good view of Pluto because the New Horizons spacecraft, which was launched in 2006, as fast as we could get it there, it took 9 years to get to Pluto. And that's because, Pluto is really far away. It's about, 4 billion miles away, something like that, 3 to 4 billion miles away. And when New Horizons got really close to Pluto, Pluto rotates every 6 days. And so when New Horizons was far away, it got one side. That's why the one side is blurrier, because it was far away. And then when it got close to Pluto, it got the really cool side, including that enormous heart-shaped feature, Tombaugh Regio. Isn't that pretty? This was astonishing to the secularists, because in their view, Pluto's 4.5 billion years old. It's tiny. It's 2/3 the size of Earth's moon. It's not very big. And being that far away from the sun, it doesn't get much energy from the sun. It should be an icicle. It shouldn't have any internal heat, and therefore there shouldn't be any geology. Geology, mountain building and stuff like that requires energy, internal heat. Pluto shouldn't have any. They were not expecting to find mountains and valleys on Pluto, but they're there. Let me zoom in on some of them here. See those mountains there? They may look small, but those are about as big as the Rocky Mountains in Colorado. And they're made of ice. At that distance, ice is as hard as rock because it's so cold. But the interesting thing is, they were expecting Pluto would just be no mountains or valleys, but just covered with craters, because there's all kinds of stuff out there to impact with Pluto. Over billions of years, it should be totally cratered. Now, there are a few craters. You can see them there, because in 6,000 years, it's had a few impacts. But this region right here, there's not a single crater in it. Isn't that fascinating? It looks like there's been some geological activity there that's erased any craters that would have been there initially. So that indicates that Pluto is nowhere near billions of years old. And likewise, its largest moon, Charon, Charon is about half the size of Pluto. They actually kind of orbit around each other. And Charon also has evidence of geology, mountains, canyons. You can see them there. A few craters, but not that many. A dark North Pole, which is kind of unique. We're not sure what causes that. So really fascinating, isn't it? And again, inconsistent with the secular view of billions of years, but perfectly consistent with biblical creation. And that's common. I'm used to that, because I study these things a lot, and I've come to expect God's word to be vindicated when we look at these things out in space. Amen. And for all these worlds, too, that we've looked at, and it's amazing, there's a special beauty to this one. And it's interesting. One of the astronauts who walked on the moon, actually two of the astronauts that walked on the moon later became Christians. And one of them said the amazing thing is not that man walked on the moon, but that God walked on the earth. And I think that's awesome. This is the planet where God came and paid for our sins by dying on the cross in our place and offering salvation to all who trust in him. Pretty awesome. The earth is very special. The earth is very special because we're made in God's image. And that's very beautiful, I think. We do have a number of resources I'd encourage you to get. This presentation, Worlds of Creation, we have that on DVD. You can get that outside there. Astronomy Reveals Creation, another talk I do along similar themes where I show how the universe declares God's glory and not billions of years or the Big Bang. The book that would go along with this, Taking Back Astronomy, showing you how it reveals God's glory. If you just sort of want a fun guide to the night sky, Stargazer's Guide to the Night Sky, how to enjoy the night sky from a Christian perspective. If you want to learn the constellations, or when's the next meteor shower, or when's the next solar eclipse, that'll tell you. If you want to get a telescope, what kind you might want to get and how to use it, and so on. That's a fun resource. Created Cosmos takes you on a tour of the universe, like we did just the solar system today. This goes through the rest of the universe briefly. And it's the planetarium show I wrote for the Creation Museum. The Physics of Einstein, if you'd like to learn about black holes and is time travel possible, and what about distant starlight, all answered in that book. If you want a bulletproof argument for biblical creation, this is it. It's very different from the kind of argument that people think, because they're thinking, well, I need to know a lot of details of science. No, you don't. Not to give a bulletproof argument for biblical creation. You just need to think the way Jesus did and argue the way that Jesus did. And that book's going to train you how to do that. The Secret Code of Creation, one of my latest books, it's going to show you how beauty has been built into an aspect of creation you probably never even thought about. And I'm going to talk about that in the third presentation we have today. Again, we have children's resources. I'd encourage you to look at those. And we're going to give you a 20% discount on all of the children's resources. So we want to get those into your hands. We do have a free monthly newsletter too. Make sure you sign up for that. Okay? And not too many things free in this world, just salvation and our newsletter. So make sure you do that. And check us out on the web as well at biblicalscienceinstitute.com. Thank you very much.
To take a little break. We have some refreshments outside. We just asked that no food or drink be brought upstairs here into the sanctuary. So we're going to be back in here at 10:40. So that's about 18 minutes from now. And we'll start with a worship song. The next topic is Creation Science Confirms the Bible. I think you'll find that to be also fascinating. So 10:40.